All right, today we're going to pull back the curtain on AI. We're going to talk about a technology that, might seem like ancient history, but is actually one of the most powerful forces shaping your world right now. So when you think of AI, what pops into your head? Probably sprawling neural networks, right? Or maybe massive language models. And look, you're not wrong, but that is not the whole story. What if I told you that the real engine, the hidden engine behind the most critical systems we all rely on, is a much older, more structured form of intelligence? Just look at this number, 1 billion. That's how many security queries Amazon Web Services processes. Not in a year, not in a month, every single day. And the wild part? It's not done with those trendy neural nets. It's all handled by formal mathematical logic, a direct descendant of the AI that started this whole thing. So here's our roadmap for this explainer. We're going to start with that hidden engine, then travel way back to the very first thinking machine. We'll ride the highs of its golden age and the lows of the AI winters, uncover a quiet revolution that happened behind the scenes, see where this logic is hiding in your life right now, and finally, we'll look at why the future of AI is, you guessed it, a hybrid. Okay, Section 1, AI's hidden engine. While neural networks get all the headlines for being able to learn and perceive, it's this older, logic-based AI that provides the reasoning and, crucially, the verification that makes our modern world actually work without falling apart. It's the unsung hero. So let's jump to Section 2 and see how this all kicked off. And it wasn't in some sterile lab with a blinking supercomputer. No, it started in a living room over the Christmas holidays. It's 1955. Herbert Simon and Alan Newell designed this program called the Logic Theorist. But they don't have a computer powerful enough to run it. So what do? They improvise. Simon gets his wife and kids, gives them a bunch of index cards with instructions, and basically has them act as a human computer. And it worked. A year later, they present their thinking machine at the Dartmouth Conference, the very place the term AI was born. This all led to the physical symbol system hypothesis, this core belief that you could achieve real intelligence just by manipulating symbols according to a set of rules. And this was no party trick. The program actually proved 38 theorems from Principia Mathematica, which was the foundational text of logic. The book's author, the legendary philosopher Bertrand Russell, even wrote them a letter about it. He said he was, and I'm quoting here, delighted. He saw the massive potential right away. All right, Section 3, a golden age and the winters. So after that incredible start, logic-based AI hits this golden age, solving actual real-world problems. But, it also kind of flew too close to the sun, leading to a series of pretty dramatic collapses. This was the great era of expert systems. You had programs like Dendril helping chemists, and Mycin, which could diagnose infections just as accurately as a human doctor, all by using hundreds of simple if-then rules. But the real commercial home run was a system called XCon. It saved a company tens of millions of dollars a year just by correctly configuring its computer systems. By the 80s, AI was a billion-dollar industry. But then, the AI winters hit. The first one came in the mid-70s. The promises just got way ahead of reality. Then the second winter around in the late 80s. The specialized computers they used became obsolete, and those expert systems, well, they turned out to be super expensive and fragile to maintain. Funding completely dried up, and overnight, AI basically became a dirty word. And that brings us to Section 4, the quiet revolution. Because while the world's attention had moved on, a small community of researchers was quietly making logic-based AI exponentially more powerful. This led to one of the biggest performance breakthroughs in the entire history of computer science. The key problem they were working on is called Boolean satisfiability, or just SAT for short. The easiest way to think about it is like a giant, ridiculously complex logic puzzle. Most versions of this puzzle are what we call NP-complete, which is just a fancy way of saying they are computationally very hard to solve. But researchers found a special, simpler version of the puzzle that used something called horn clauses. And these were solvable in linear time, meaning computationally very easy. This insight was the absolute key to building systems that were both powerful and incredibly fast. Building right on that foundation, a series of breakthroughs in the late 90s and early 2000s created what we now call the modern SAT solver. Systems like GRASP, CHAF, and MiniSat introduced brand new techniques for learning from mistakes and searching for answers way more efficiently. Each step brought these massive speedups, turning these theoretical tools into absolute powerhouses. Okay, Section 5, Logic in Your Life. So what does this quiet revolution actually mean for you? Well, it means this technology is now silently running the invisible infrastructure of your entire world.
Seriously, it's everywhere. From verifying every single transistor in the chips in your phone, to scheduling airline flights, to securing your data in the cloud, and even finding critical security bugs in software before the hackers do. Modern logic solvers are the unsung heroes.
This is a perfect example of the impact. When the airline Ryanair used a logic-based optimizer just for its fleet in Italy, it saw a 38.1% increase in seat capacity. That's 3 times its network average. A massive, massive gain in efficiency, all powered by formal logic. And this is the really crucial point. Before a modern chip from Intel or AMD ever leaves the factory, its design is formally verified using these logic solvers. They check for errors at a scale that no human team could ever dream of managing, and that's what ensures the technology you depend on every single day is reliable. And just to give you a sense of the insane speed we're talking about, a modern SAT solver can solve over 8,000 unique Sudoku puzzles per second. That's the kind of horsepower we are dealing with here. And now for our final section. The future is hybrid. So we've seen the world of logic and the world of neural networks. For a long, long time, they were seen as rivals, as two competing tribes of AI. But the future of AI isn't about one winning. It's about bringing them together. You see, the two approaches have these perfectly complementary strengths. Neural networks, they're phenomenal at learning patterns from messy, real-world data, but we often have no idea why they make a certain decision. It's a black box. Symbolic logic, on the other hand, gives you provable correctness and clear reasoning, but it can be brittle when it faces uncertainty. The real cutting edge of AI research right now is in what are called neurosymbolic systems that give you the best of both worlds. DeepMind's alpha geometry combines a neural net's intuition with a logic engine's rigor to solve incredibly complex geometry problems. Systems like Deep Problem can literally learn to add numbers just by looking at pictures and applying the rules of math. And this isn't just theory, it's already powering Amazon's warehouse robots. As the AI researcher Gary Marcus puts it, the only way we're going to build richer, more capable AI is with this exact combination, the learning ability of neural networks, paired with the structured reasoning of symbolic logic. So if there's one thing to take away from all this, it's that logic isn't some dusty relic of AI's past. It's the verification layer making sure our present technology actually works, and it's the reasoning engine that's going to be absolutely critical for building a smarter, more trustworthy AI in the future. Which really leaves us with a final question to chew on. Over the last decade, AI has made these unbelievable leaps in perceiving the world, in learning to see and hear and read. The question now is, by finally combining that amazing perception with the power of logic, is AI finally learning how to truly reason?